Welcome! In this explainer, we're going to break down one of the most fundamental rules of our universe, Newton's third law of motion.
So here's what we've got lined up. We'll start with the core concept, then look at some everyday examples, even on the sports field. We'll solve a common puzzle about motion, and then we'll see how this law literally takes us to the stars.
All right, let's start with a simple action you do every single day, an action that hides an incredible secret of physics. Think about this for a second. When you walk, you are literally pushing the entire planet backward. So why on earth do you move forward? It seems totally backward, doesn't it? Well, the answer is in this universal law of push and pull.
Okay, let's dive into the official definition of this incredibly powerful principle.
So what does this actually mean? It means that forces in nature, they never just show up by themselves. They always, and I mean always, come in pairs. And the whole idea is wrapped up in this simple but profound little equation. Force 1 equals negative force 2. Now, that minus sign is the key. It doesn't mean the force is weaker. It just means it's pointed in the exact opposite direction. Equal punch, opposite way. Now, here's the cool part. Once you know this law, you start seeing it absolutely everywhere. Let's look at how this action-reaction thing is happening all around us all the time. Every time you swim, you're using Newton's third law. You push the water back, that's the action, and the water pushes you forward, that's the reaction. Same goes for a bird pushing air down to fly up, or a rower pushing water back to move a boat forward. Even that recoil you feel from a gun, that's the bullet pushing the gun back into your shoulder. Okay, let's take this same idea to the sports field. Athletes, whether they realize it or not, are basically masters of this principle. They use it to do some pretty incredible things. Think about a sprinter or a long jumper. To launch themselves forward, they don't just, step. They powerfully drive their feet down and back into the ground. That's the action force. And what happens next? Well, the ground pushes back on the athlete with an equal and opposite force. That reaction is what actually shoots them up and forward. You can see it right here in the phases of the jump. It's that reaction force that gets them into the air. So here's the deal. To actually move upward, an athlete has to generate a force that's greater than their own body weight. For instance, if their weight is, say, 1,000 newtons, that's just a unit for force, they might need to push down with 1,200 newtons. That extra 200 becomes the net upward force that lifts them off the ground. Okay, so this brings us to a classic puzzle that really trips a lot of people up when they first learn this law. It's a great question, and it gets right to the heart of how this all works. I mean, it makes perfect sense to ask this, right? If every single push has an equal and opposite pushback, shouldn't everything just be stuck? Shouldn't it all just cancel out, leaving us in a cosmic stalemate? And here is the solution. It's actually brilliant. The forces in an action-reaction pair never cancel each other out. And why not? Because they are acting on two completely different objects. The horse's pull acts on the cart's pull acts on the horse. Since they aren't acting on the same thing, you can't add them together. To figure out if the horse moves, you only look at the forces on the horse. The forward push from the ground on its hooves has to be stronger than the backward pull from the cart. To see if the cart moves, you only look at the forces on the cart. The forward pull from the horse has to be stronger than the backward drag from friction. They're two completely separate problems. Now, let's talk about maybe the most powerful and awe-inspiring application of this law, which is how we manage to leave our own planet. A lot of people think a rocket pushes against the ground or the atmosphere to fly. It actually doesn't. A rocket pushes against its own exhaust gas. The action is the engine blasting that gas down with incredible force. The reaction is that gas pushing the rocket in the opposite direction, up. And that's why this law is just so fundamental. It allows for movement even in the total vacuum of space, where there is absolutely nothing to push off of. The rocket brings its own pusher with it, in the form of its fuel. And that leaves us with a final thought to chew on. If you're an astronaut floating out there in the void, how do you get back to your ship? You can't swim, you can't push off anything. The answer, of course, is all in the law of action-reaction, the key to navigating that final frontier.